Well, another interpretation of fine-tuning might be, well, of course the universe is fine-tuned for life, otherwise we wouldn't be here pondering about all this. What are your thoughts on that?
It's an objection that you can state very forcefully. Elliot Sober has done this. It's probably the best example of that. He's a philosopher. You can say this very, a square circle isn't possible, right? So what would we think about someone who walked around saying, isn't it amazing that you just never see square circles anywhere? That's incredible. Well, it's impossible to observe a square circle, and then it's impossible for life to observe a universe which doesn't permit life. It's just not logically possible. So any life anywhere of any form must observe a universe that permits life. So how can you be surprised? So it's a very forceful objection. I think we can apply that sort of reasoning to an analogy. Now, this is another one from John Leslie.
50 trained marksmen who miss one time in 1,000 have their rifles trained at your chest. Ready, aim, 50 guns go off. And as the smoke clears, you're still alive. How did that happen? Would it be enough just to say, well, of course the bullets missed, otherwise I wouldn't be here asking the questions. Hopefully that shows what's wrong. What we want to know is, how did that bullet, which started over there, miss me? Why are there 50 bullets behind me and none in me? See, the fact that I'm alive afterwards didn't make the bullets miss me. Hey, maybe someone bribed them. Maybe they missed on purpose. Maybe they've been doing this for so long they had to miss someone eventually, and the person they missed is always going to go, oh, how did that happen? But just saying that I'm alive afterwards isn't a cause of it.
In 1963, an astronomer, Martin Schmidt, discovered that quasars are very distant celestial objects from their very large redshifts. And because of this, it was discovered that they're very luminous objects. They're very far away. So the question is, why are they so luminous? So I'm going to propose two hypotheses, or two explanations as to why they might be so luminous. Here's the wrong answer. Because if they weren't so luminous, we wouldn't be able to see them. If we see an object in the distant universe, then it must be very luminous. Well, that's not really an explanation. So here's the right answer. Quasars are powered by the gravitational energy released by matter falling into a supermassive black hole. So the moral of the story here is that noting that if we observe an object in the very distant universe, then it must be very luminous, does not explain why the object exists in the first place, or what gives it its high luminosity. Right? It's simply stating a necessary condition for us to observe that quasar. It doesn't explain why that quasar exists in the first place. Okay? Similarly for our universe. Merely given the anthropic explanation doesn't explain why there is a fine-tuned universe to begin with.
We could only be living in the kind of universe which is capable of giving rise to us. So the fact that we are observing anything at all means that we are in that kind of universe. Now, some physicists stop there and say, end of story. Because we are here, we in a sense create the necessity for the laws of physics that make it possible for us to be here. I agree with those who don't find that totally satisfying. The philosopher John Leslie expresses his dissatisfaction with it by imagining a man facing a firing squad, and there are 10 men in the firing squad. They all aim their rifles at him. The rifles will go off, and he finds himself still alive. And so he says to himself, well, obviously the rifles all missed, because otherwise I wouldn't be here. But that leaves unexplained why the rifles all missed. You still feel you need an explanation for why they all missed.
I'll put it in another form, because we're on the internet here. Suppose that you're sitting on the porch of your grandpa's home and he says, Luke, I've got to tell you something. I'm Magneto. What? You're one of the X-Men? Yes, Luke, I'm one of the X-Men. Well, and he pulls a set of keys out of his pocket and makes them levitate a little bit. And yeah, it's a great magic trick there, Grandpa. That's fantastic. And then on the hill above your house, a train derails and the carriages fall off, and it's a cargo train. And for some reason, what in hindsight is a pretty bad idea, they've packed these full of TNT and the Ginsu knife. The carriages explode, and 50,000 knives and enough shrapnel to make several rail carriages. It flies towards you and your grandpa.
Oh boy.
You duck and flinch, and then 2 seconds later, you're alive, and grandpa's alive. And you turn around and you look at your house, and there's 50,000 knives stuck into the front of your house, except for two tiny little silhouettes where you are and where your grandpa is. And he looks at you and smiles and gives you a wink, and you say, well, it's logically impossible for me to observe that I'm dead, so of course all the knives missed me. I think something's gone wrong there. And if you're not convinced that something's gone wrong there, it happens again. Another train derails, and then another one. And they're still packing these things full of TNT and the Ginsu knife. And then, a plane crashes, a malfunctioning tank flies by, the Society for Blind Snipers wanders past. The house is gone. There's nothing left. All the material in the world has come past. The firing squad from the initial analogy takes another shot. An angry neighbour throws a frying pan. And all that's left is just you and your grandpa in a tiny little square of the porch. And after all that, you have to say, well, I just can't reach any conclusions here, Grandpa. Something's gone wrong here. And I think as an astronomer, we deal with these things all the time. The anthropic principle, as this thing is called, the idea that life must observe that it's in a life-permitting universe, it's best understood as a selection effect. Now, astronomers are very familiar with these. For example, if you look way out in the universe, you're not seeing a random collection of objects. You're seeing the brightest objects.
Mm-hmm.
Because to see something out there, it's got to be bright enough for you to see it. And so we have to be very careful as astronomers, because we're not getting a random sample of the universe. We're just seeing the bright. It'd be like going into a mall and trying to get doing a random survey and just surveying all the loudest people. That's not a random sample. So now think about the discovery of what are called quasars. They thought these things were stars, and then someone discovered, no, actually, they're not in our galaxy. They're way, way out in space, hundreds of thousands of times further away. So that they must be extremely bright, right? If we can see them that far away, they must be incredibly bright. So now you ask the question, why are quasars so bright? And suppose someone answered, because otherwise we wouldn't be able to see them. Well, that's true, but it's not the sort of explanation we're after. The sort of explanation we're after is that Donald Lyndon Bell gave in 1969, where he proposed a model where quasars, there's a supermassive black hole, and as the matter is falling towards the black hole, it gets really fast and compressed, and all the energy is released, and that's why they're so bright. So if you think about those two explanations, both of them can be true, but only one of them is the sort of explanation we're after. So you can explain it like this. The selection effect in astronomy, it does explain why we don't see faint objects, but it doesn't explain why we do see bright ones. Yeah? So I think the anthropic principle is like that. It does explain why we don't observe a life-prohibiting universe, but it doesn't explain why we do observe a life-permitting one.
Right.
Because it's not a causal explanation. The anthropic principle on its own doesn't explain the fine-tuning of the universe.